We have another example on the board. I'm going to start solving this problem from finding Z total. Please notice that we have given resistance and impedance of the inductor. And because this is series circuit, we're supposed to add them up. So if Z total is equal resistance plus ZL. Resistance is equal 60 ohms plus impedance of the inductor 130 ohms, and do not forget about the angle. ZL is always with angle 90 degrees. This is equal Z total has value 143.17 ohms and angle of 65.22 degrees. This is the value of Z total. Next, we're supposed to find voltage source. Voltage source I'm going to find by using Ohm's law. Voltage source is equal I total times Z total, where I total RMS is given is 25 milliamps times Z total, which is equal 143.17 ohms, is equal 3.57 volts. Someone is going to ask me why I'm not using the angle, because I assume that my voltage source is supposed to have angle 0 degrees. That's why I'm going to add over here angle 0 degrees. Okay, so I found the voltage source. Next, I'm supposed to find the angle which is going to be next to the magnitude of current. Current I total is equal voltage source over Z total. Okay, so I have voltage source, which is 3.57 volts and angle of 0 degrees, over Z total, which is equal 143.17 ohms and angle of 65.22 degrees. Please notice that I'm doing everything step by step. So I have answer 25 milliamps, the same magnitude, and angle of negative 65.22 degrees. Okay, so please notice that the angle which I'm going to have next to the total current is the same angle which I have next to Z total, but with the negative sign. So if you remember that, you don't supposed to do this calculation, but I'm doing that because many students ask me why I have negative angle. That's why I do some extra steps, especially for those of you who have difficulties to see why I have negative sign next to the angle. Okay, so next we're supposed to find voltage across the resistor. So I have I total, and please keep in mind that I total in this case is equal to the current which will go through the resistor and is going to be equal to the current which goes through the inductor. Why? Because this is series circuit. Next, we're supposed to find voltage across the resistor. This is equal IR times resistance, where the current which goes through the resistor is 25 milliamps and angle of negative 65.22 degrees times the resistance, which is equal 60 ohms. everything is equal, 1.5 volts and angle of negative 65.22 degrees. Okay, so this is voltage across the resistor. Next, I'm supposed to find voltage across the inductor. VL is equal IL times ZL. I'm using again Ohm's law. So I have 25 milliamps and angle of negative 65.22 degrees times ZL, which is equal 1 toriohms and angle of 90 degrees. This is equal 3.25 volts and angle of 24.78 degrees. Okay, so this is the voltage across the inductor. Someone is going to say, okay, I found the voltages, so I can continue, I can go to power factor. But it's always good to check if your answers are correct. You're supposed to use KVL to verify your answers. You're supposed to realize that if you are going to add these two values, you are going to get the voltage source. So let's check if this is going to work. So we have voltage source is equal VR plus VL, where VR is equal 1.5 volts and angle of negative 65.22 degrees plus 3.25 volts and angle of 24.78 degrees. This is equal 3.57 volts and angle of 0 degrees. So please notice that the value which we obtain is equal to the value of my voltage source. So it means that these two values are correct. Next, we're supposed to find the power factor. Power factor is equal cosine of angle theta. So I have cosine of the angle, and my angle next to the 65.22 degrees is equal 0.419 lag. Why lag? Because my angle is positive and because I'm dealing with the RL circuit. In the RL circuit, the current is going to always lag the voltage source. That's why I'm supposed to use word lag next to the value of the power factor. Next, we're supposed to find the reactive power. QL is equal IL square times ZL is equal 25 milliamps to the second power times ZL, which is equal 1 toriohms, and this is equal 81.25 milli VAR. So we can say that the problem is solved.